All right, welcome. It's Mr. A again with a little bit more from section 3.1. In this part of section 3.1, we're going to talk about substitution. Now remember, before we graphed two lines to see where they would cross, and where they crossed, that was our solution. We're basically looking for the same thing here. This is just another way to do it where we don't have to graph, okay? Because we didn't do an example like this, but if you had an example that didn't cross right at a good spot, it didn't cross right at, 2, 1 or 1, -4, let's say it crossed somewhere in between, you go, well, is that 1.5? Or is that 1 3/4? Is it 1 1/4? Sometimes it's hard to tell what the solution actually is when you graph it. So there are other ways to do the same thing. But it was important to do the graphing because you can kind of get a good sense for what it looks like. You get a feel for how it looks. So this is another way to solve the same type of problem, but without graphing. We can use substitution. Okay? We get the same type of answers. We're either going to get one solution, infinitely many, or no solutions, all the same stuff. Okay, so this should go a lot quicker than the last one. All right, our objective for today, solve systems of linear equations using substitution. All right, here are the steps. I'm going to go through these. It'll probably make more sense when we actually do them, though. Number one, solve one of the equations for one of the variables. It doesn't have to be y equals. It could be x equals. It doesn't matter which equation you get x by itself or y by itself, as long as it's x totally by itself or y totally by itself in one of the equations. You don't have to do it in both, just one. Okay? Number two, take what you've got, what x equals or what y equals, and plug it into the other equation for x or y. Then you solve that equation, which will tell you x or y depending on which one you got rid of. And then the fourth thing is you put that back into one of the original equations to find the x or y that you didn't find. Okay, sounds a little confusing, but it'll make more sense when we actually go through the steps here. Okay, all right, let's try a few examples in. Here is one of our situations. We're going to do substitution. Now, my high suggestion here is look at what you've got. You've got a 5x, a 3y, a 2x, and a y. I am always going to try to get by itself the x or y where there's not a number in front of it, typically. Because in this case, if I get x by itself, I'm going to have a 3 divided by 5, or 23 divided by 5. If I get this y by itself, I'll have 5 divided by 3, or 23 divided by 3. I'm going to have some weird fractions. You can do it, but it's not going to be easy. The easiest thing is look at the second one. Let's get that y by itself. All I have to do here is go minus 2x, minus 2x. And so I see that y will equal negative 2x plus 7. That's a lot easier than 23/3 or 23/5 or 3/5 or 5/3. Okay, so this is a lot easier. All right, so here's what I'm going to do now. I'm going to take this, since y is the same thing as negative 2x plus 7, since those things equal each other, that means that they're the same thing. Okay, so in the other equation now, notice I have 5x minus 3y. I'm going to write that as 5x minus 3 times not y, but y is the same thing as this negative 2x plus 7, so I'm going to write negative 2x plus 7 and then equals 23. So what I did was I substituted, there's the y, I substituted in its place negative 2x plus 7. It's just like, say, in a football game. It's like the y up here is your starting middle linebacker, and he twisted his ankle, and we had to make a substitution. So we said, okay, next guy up, you're in. So who's the next guy up? In this case, it's negative 2x plus 7. That's the backup middle linebacker because they're both middle linebackers, and so I'm going to take negative 2x plus 7 and plug him in to the place where the starting middle linebacker was. Okay, so that's all I'm doing. Now you notice when I do that, though, all I have left is an x and an x. So that means I can solve what I've got left here and find out what x is. Okay, how do we do that? Distribute this negative 3. So I'm going to have 5x plus 6x. Negative 3 times negative 2 is a positive 6. Then negative 3 times 7 is negative 21. Combine the like terms. So 5x plus 6x is 11x. Add 21. So you have 11x equals 44. Divide by 11. X is 4. Yay! Am I done? Not yet. Got one more thing. The good news is I don't have to go through all these steps again. It's from here on in, it's very simple, but I do have to do one more thing. I know what x is. I have to find out what y is. You could go back up to this original equation and plug x in and solve for y. You could go to this equation and plug x in and solve for y. I would suggest the one where you got y by itself, let's use that one. That's going to be the easiest one. So this one here where we have y equals negative 2x plus 7, let's plug 4 in up here for x. So I'm going to have y equals a negative 2 times 4 plus 7. So that means this is going to be negative 8 plus 7, which means y is negative 1. So what is our solution for negative 1? Remember how we got solutions before where it was ordered pairs? That's exactly what we're going to do now. Notice for negative 1, it looks just like those first couple of answers that we got on the last video. So for negative 1, we just got a point. That's where those two cross. If you took both of these equations and graphed them, you know where they'd cross? At 4, negative 1. Same exact answer that we would have gotten the other way, but we don't have to graph. Okay? Example 2. We're going to go through the same steps, but this time let's look at this and go, well, which x or y would be the best to get by itself? What do you think? Take a look. Okay, if you said this x right here, you're correct. Okay, so way to go, Madison. Let's get that one by itself. So I'm going to do plus 7y, plus 7y. These cancel, so now I have x equals 7y plus 11. So I got that x by itself. Now all I do is I take, since x and 7y plus 11 are the same thing, this would be like, oh, let's say x is your starting running back. And he gets injured, and so your backup running back has to come in the game. Your backup running back is 7y plus 11. And so you say, okay, in the other equation here, we say, all right, we have 5 times x, but you go, ooh, x got injured, so we have to put in 7y plus 11. And then you have the rest of it here, plus 4y equals a negative 23. Now we just solve that. Take the 5, distribute. That's going to be 35y plus 55 plus 4y equals a negative 23. Combine your like terms. You've got 35y and 4y, which is going to be 39y. Kind of at the same time here, I'm going to go minus 55 just to save some space. Notice when I combined the two things that were on the same side, I didn't do the opposite thing. I just combined them how they were, 35 plus 4. But when I combined the things that were on opposite sides, I did the opposite equation to move it over. So since it was plus 55, I did minus 55. And that's going to give me then negative 78. and then divide by 39. And so we end up with negative divided by positive is a negative, and 78 divided by 39 is 2. So y is a negative 2. Yay! Are we done? Not yet. We got to find out what x is. So again, you could go back to this first original equation or the second original equation. I would suggest going back to the one where x is by itself, this one right here. And so let's plug it in there. So you've got x equals 7 times y, which is negative 2, plus 11. So that means it's going to be a negative 14 plus 11. And so that's a negative 3. So x is a negative 3. So my solution is negative 3, negative 2. Just like before. In the last video, we got a point, a combination of x and y. And if you took both of those equations and you graphed them, you know where they'd cross? At negative 3, negative 2. Just like before. All right, one more example and we're done. How about this one? Which x or y do you think you'd like to get by itself? What do you think? What do you think, Grant? Do you say the x on the top one? That's it. Yeah, let's do that one. So minus 5y on both of them. So I'm going to have x equals negative 5y plus 4. Okay, so we got these together. Now we're going to make a substitution. So let's say this x this time, oh, he was your starting center, and he got injured. And so we had to put in the backup center, which is negative 5y plus 4. So in the other equation, we have 3 times x, but x got taken out. Now we had to put in negative 5y plus 4. And then plus 15y equals negative 1. How do we solve it? Let's start by distributing this 3 here. So that's going to give me a negative 15y plus 12 plus 15y equals negative 1. Combine the like terms, so we go, okay, I got negative 15y plus 15y. Uh-oh. What's going to happen when we combine those? They cancel each other out. So what do I have left? I have 12 equals a negative 1. What in the world does that mean? Well, remember before what our possible answers were? It could be one solution where we'd have an x and a y. We could have no solution where the lines were parallel, or you could have infinitely many solutions where the lines were right on top of each other. What do you think if you got 12 equals a negative 1? What do you think that would be? Do you think it'd be infinitely many, or do you think it'd be no solution? Does 12 equal a negative 1? No. So this is how it looks when it's a no solution. That would be a no solution. When all of the variables cross out, which they did here, and all you have left are numbers, then look to see if they equal each other. If they equal each other, it's infinitely many solutions. If they don't equal each other, it's no solution. So in that case, it's a no solution. If I did, work something else out here, and let's say I end up with 13 equals 13. Well, if I got something like that, that's true. 13 will always equal 13. So this is where we would say infinitely many solutions. So those are the two other things you could get. If they don't equal, no solution. If they do equal, infinitely many solutions. Okay? Just notice here, I've drawn a line between these, so this is not the same equation. This is a totally different example here, in case you get confused. Okay? That's all there is to substitution. Hope you enjoyed it, and we'll see you next time. Bye.